My name is Rex Pruitt. I am a systems engineer for SAS and also serve as the Hadoop Adoption Technical Advisor. This is the first in a series of videos featuring how SAS interacts with Hadoop, sponsored by the Hadoop Adoption Program. The first video in this series is about Hadoop architecture and the mechanics of it. The slide I'd like to cover first is really about collaboration amongst the players involved in using SAS to interact with Hadoop. Number one, you have your administrators. They have to build the environments such that they will work together. You can see at the top, I have an arrow pointing between the Hadoop administrator and the SAS administrator. Point one is that these two need to really work closely together, and in large organizations, they typically do not. Therefore, it takes some extra effort for them to be able to collaborate on configuration and getting the handshake between SAS and Hadoop to work effectively. When we talk about a handshake, we mean the ability for the SAS server and or desktop client to be able to connect to the environment using either a connect to protocol or a live name statement. That leads us to the point number two. In order for any of these handshakes to work between the two environments, there are certain configuration and jar files that have to be in place both on the SAS side and the Hadoop side, and they have to match. Therefore, configuration is not easy. However, SAS has gone through this many times, and our tech support team is ready and willing to help when configuration complications occur. Of course, the best way to address this is to engage in our professional services support and have them help configure the environment. And that leads us then to point number three on this slide, and that is the user interaction. Understanding that the configuration between these two environments is not the easiest thing to achieve, the SAS users need to be patient and work closely in collaboration with the Hadoop administrator and the SAS administrator in communicating any complications they encounter, capturing as much log information from their SAS interaction as they possibly can, and provide that information quickly to the administrators for their diagnosis and remediation. And of course, again, tech support is ready and willing and very capable to help resolve many issues that might be encountered. So please work in concert with one another and leverage SAS resources as much as possible in order to achieve success. I even recommend that the administrators meet regularly, if it means one taking the other out for lunch, at least once a month, to stay abreast of what's going on in their respective environments. This particular depiction is a metaphor that I use to try and explain to SAS users or even those who may not be SAS users yet, but they want to understand a little more about how Hadoop actually works. From an architecture and a processing standpoint, I've chosen this metaphor, which is a library. And most people have been to a library. All the information is placed on bookshelves or in areas where it has to be referenced through a card catalog, and everything is numerically assigned and categorized accordingly by subject, and all of those nice conveniences that make it a little easier to go and find what you need in a library. However, the librarian is always a critical component to being able to access things efficiently and effectively in a library, because there could be various copies in different orders and different areas of the library, and the librarian generally knows where those things are and how to get to them as quick as possible. Of course, a librarian oftentimes has helpers taking care of the library and retrieving information and placing information back where it belongs. Well, we're going to correlate this to Hadoop. And there are some contrasting points as well. In Hadoop, it's a distributed environment, much like a library's bookshelves, if you will. You have worker nodes, and worker nodes are various computers or servers. Each one of those houses components of the data or files that are placed in the Hadoop cluster. The librarian in this metaphor is likened to the master node. And the master node keeps track of everything that's going on. Now imagine a library where all of the books are just scattered and redundantly placed on many different bookshelves, such that if a bookshelf burned up, you would still have a replicated copy of it somewhere. Well, that's the same way Hadoop works. The difference is Hadoop is randomly assigning the mappings of those data files that are placed in the Hadoop cluster or in amongst all of those worker nodes. And the librarian or the master node is the only one that knows where everything's at. And so it's critical that the master node be maintained properly, possibly even having a redundant master node in case something were to happen to that particular server. So let's get into the processing component. That's how things are stored. So as a SaaS user, your interface could be anything from Office Analytics, Enterprise Guide, SaaS Studio, what have you. And you want to connect into the Hadoop cluster. So you go through your SaaS instance and try to get the handshake we talked about in the previous slide. And once that handshake fully happens and you're now connected to your Hadoop cluster through a live name statement or connect to, then you send down your request, which could be the Hive QL or some direct file access command into the master node, because you have to go through the master node to get to the information as it's distributed out in that environment. So the master node or the librarian takes the request, says, yes, I can process this, sends the request out into the worker nodes, grabs the information through a MapReduce process, and sends it back to SaaS for your consumption and processing further. If possible, all processing should be done in the Hadoop cluster. This is not a case where we want to do a select star and pull all that data back to SaaS, when we can effectively leverage the massive processing in the Hadoop cluster of all those servers and the memory allocations there to do the heavy lifting and then send a smaller result set back to SaaS for further analytics. Here's how the basic constructs layer into the Hadoop cluster. The lowest level of existence in the Hadoop cluster is the Hadoop distributed file system, which is basically the underpinnings of the operating system. And typically an operating system in the Hadoop environment will be Red Hat Linux or something like that. Then we layer on some additional support resources in the environment, Yarn being one of those, which is yet another resource negotiator. If you're familiar with Grid for SaaS, that is a way of distributing or parallelizing your SaaS code. So TK Grid helps manage those resources in those servers that you have mapped together. In a Hadoop cluster, Yarn is the open source version of that helps manage the resources in the Hadoop cluster. And that's what it's managing is really a bunch of MapReduce jobs, which is executed typically in Java, and the data or information files are all pulled back together based on those mappings that were established by the master node or the librarian, where that data is stored out in the Hadoop distributed file system. And so those tools help manage that workload and what jobs run in what order. Then we layer on some additional capabilities, scripting language called Pig. It's great for joining data, transforming data native to that Hadoop environment. Then there's the SQL language that's placed typically in a Hadoop cluster called Hive. And then sometimes there's a high performance type of engine in play. If they have Cloudera, maybe that would be Impala, or maybe they would have Spark. But if you have MapR or Hortonworks, you wouldn't have Impala, but you could still have maybe Spark or something like that. Here's an example of a Pig program. You can execute these through our proc Hadoop, through your SaaS interface, or you can log on natively to the Hadoop cluster and execute code similar to this. And then here's an example of Apache Hive. And this, again, you could log natively onto your Hadoop cluster if you have permissions to do such a thing, and invoke a Hive instance and actually execute some code native in that environment through your native Hadoop user interface. You can also submit these directly into Hadoop from your SAS interface using some capabilities where you do a connect to and pass this code in a ProcSQL type of code execution. That brings us to the end of the architecture discussion. Thank you for watching. And should you have any questions, please reach out to me directly, or you can contact your customer success manager or account executive, and they can connect you with the right resources to answer your questions.